and it is a great occasion for me, a great experience for me to address so many brilliant minds. My future colleagues probably, future scientists, potential researchers for new India, maybe new world. When I got this invitation verbally from Ramadip, and then formally from Vikas and some other friends from here, I took it very lightly. I thought it is just the electromagnetic groups and they were trying to get me and I would talk on something, on E cross H, something like this. Nothing beyond that. And suddenly something came to my mind that research scholar did. So I asked them, is it for you, only for the electromagnetic group or whole electronics? So immediately conveyed that no, it is for the whole electronics. So I changed my thought. But today, right now, or after coming over here, I am feeling a bit nervous because so many illustrious scientists, my friends, colleagues, the researchers, the robust researchers of this institute, they are sitting here. So let me try. And I'm not very happy in making my presentation. I did it within last 3-4 days. I had not much time in hand. This is the first presentation. Maybe a few mistakes are over there, but I will definitely make it more clearer or improve for you in the future. So should I start? Question is, am I really going to tell you something? No. What's the difference between you people and me? Just few years, because I had to cross all the paths. I also started like you. So it's just few years difference, that's all. So I can share something that happened to me and I realized something on my own way. This is true for our lifelong. We'll have to start the whole life because we'll have to survive on problem. A researcher cannot survive without proper problem. So you have to be idle. So don't get frustrated. This thing will also happen in your mind, but not very frequently. If it happens very frequently, you should be very happy. So we'll have our new ideas, new things. Unfortunately, the projector is not working perfectly, that's why you're not getting proper picture, proper contrast, proper color. As a PhD student when I started my career, like all of you, this is the only slide. We have to have our own problem and find solution, publish some papers and get my degree. That's all. So this is actually a problem for the supervisor or for the students. So it depends. So for me, it happened in a different way. My supervisor, he was from same department, Professor P.K. Shah. He asked me to solve some problem because when I joined in 1990, since 1986, he was solving some interesting problem numerically. He already published that time, in particular topic, 4 papers in the MTT, IEEE transactions on microtheory and techniques. And he immediately gave me the problem, and first paper I published after 9 months of my journey. So from that point, it was very easy for me to get the problem, but I faced some problem later on. That is after doing PhD. There's so many crossing, so many paths, and it's very difficult for you to choose which one is for you, which is good for you. So your professors, they face the same problem. All the researchers face the same problem after doing PhD. So I'm covering all these things because I had to cross this path, not in a very smooth way. Summer 1996, I got my degree in 1994. It is due to URSI. Have you heard the name URSI? International Union of Radio Science is one statutory body of UNO. It controls the whole international program, allocation of frequency and many other things. So RC, that year, the General Assembly, every 3 years happens. It was in France, my first visit to Europe, but not by spending my own money. RC funded my whole trip as the young scientist recipient from India that year. It happened over here, Lille, the north of France. Just after crossing Lille, you can enter into the land of UK, Grand Palais. I never have seen such a big convention center. There are 2,000 people, and it was very difficult to find out a single one twice. I had one intention before going over there to meet this person. From electromagnetics group, can you identify the person? Tatsuo Ito. Ito was commissioned the chair. He was editor-in-chief of MWCL. It was a big name, and our dream, and most of us at that time, in any part of the world, we had dreamed to work with Ito. Somehow, I could manage my contact him, and he fortunately gave me 5 minutes time to walk from one building to another building. Japanese American, and I found the time is tight, and he gave me exactly 4 minutes, and that's there. He asked me, while you are very nice, you are welcome, but what do you do? I told my topic. Come to my next. That's my change of life. Just within four minutes time, he asked me to read his article. He asked me to read his article. Read his article in this 1996 book published by RC, and that was on active antenna. So that's the introduction of antenna in 1996. I was totally in a different field of electromagnetics. And he told one thing that is very important for you, I'm sharing, that you should choose right now your topic so that you can continue for next 20 years at least. So choose the right one, which is the growing part. That is the phase of learning for next 3 years. I had to learn on my own lot of journals and books. And for any research scholar, any research student, it is the only thing to learn to read, or by reading, or through reading. If you cannot understand by your first reading, definitely the second reading is better, clearer to you. If it is not, in the third reading. If it is not, in the fourth reading. One day you will find it works. This is one thing. And second one that I have learned in a different way, that ask your question. You have to have your question. If you don't understand anything, you ask your question. I am telling the experience. I had one critical question in my mind. I read many papers, they are writing many things, but I couldn't understand why and why. So I asked it. Almost everyone, every scholar in this field, in this country, when I met them outside, I did not get my answer from them. I got my answer through working and just by thinking that this could be, this could be, this could be. And by this way, one day I found that is the right way. But it took nearly 10 to 11 years time. So you have to give time. So after this fall, I got it. I found one good paper from the other group, probably the electromagnetics students in Harvard, Kai Chan, who is now the series editor of Wiley, right? So I solved this problem. I found the problem because they were handling one project from NASA, but every time they were going on experimenting. They had no theory to understand or calculate the internal characteristics. So I found the problem that is the thing, which is still unsolved, and I can do it. But success came in different form. To address that problem, that was one microstrip with inverted configuration, I had to understand microstrip circuit or antenna in its conventional configuration. And when I tried to understand this, I had to go through all the contemporary papers and found there is something missing. Combined all these things, I was alone, no PhD student was available those days very easily. That is the time when the student used to go to industry. So it is my. Can you read this paper? No, I think is it visible?
Yeah.
Is the year is visible? No. It's 2001. It is absolutely blurred, single authored paper published in 2001. So success came in 2000. It was accepted in 2000 during Guha period. As you can remember, just on the day of Shoshki, I got this letter. No email was working still then from my IEEE. I IEEE started online probably in 2002, 2003, as far as I recall. Sorry, probably you cannot see this thing. So the problem I addressed from the NASA project of Kai Chan, that I addressed later on. So my aim to convey this message that attend conference, it is very important for all of you. Meet potential people, get new friends, ask them questions, get new ideas, and cannot survive alone in this world. So in the future you will realize, if you don't get idea, at least you can get good friends. And if you get good friends, definitely one day you will be benefited out of it. So let's look back. Nowadays, our searching of problem, our finding of problem, you are little bit experienced. seniors are more experienced. But what did they do? That I try to understand. Throughout my life, when I was a student like you, I was trying to understand the development of my topic or subject. That is one insight that gives you. I'm addressing two things. One is J.C. Maxwell, big name and stalwart, and most all of you have read his equations and his predecessors. And if we discuss all these things, we will find the finding out problem is of different kinds. It cannot be unique. No, you are not getting this. It is actually, please come over here. Please come over here. You just look at this. And you see what they are saying.
Sir, I just changed the context.
Please do it. I think there's a problem.
बोलो
Just not the correct
One?
बोलो प्लीज बोलो
Increase the contrast. The top two he got from Gauss, the bottom one from Ampere, the middle one from Farad. And we all know that his contribution is in here, not at all. It is actually the last work in this series was done by Faraday in 1831, that is the birthday of Maxwell. And Maxwell, you see, wrote his first paper in 1856. What is this? His age that time, you just think of. He was born 31. It is 1856. He was 25. So first he addressed Faraday's lines of force. In 63, he wrote 3 papers altogether. 61, after a gap of 4 or 5 years, he changed the topic and title. He wrote on physical lines of force. His last paper he wrote in 1864. The dynamical theory of the electromagnetic field, which should the whole world. Not because of the equations, because it was too difficult to go through the equations. It was 20 equations and 20 variables, and all in algebraic form using potentials. So he wrote few sentences, few statements which are against our conventional concept. One is the electromagnetic wave propagates, and second one the conjecture that light is electromagnetic in nature. So it is the process. His research is the process of assimilation and giving new concept, adding new concept to other works. So problem did not come from top. Problem came from the bottom, based on the earlier works. I will go through the earlier works later on, but you see, his contribution was just to combine, just to find out the flavor of each works and combine them to give the world totally a new concept based on which the new wireless world survives. So, thought is one important aspect throughout the career of any researcher. Active mind, active brain, clear idea, open mind, honest activity is very important for any researcher to survive, to become successful. Come to Ampere. Ampere was a French. He was sitting in France that time. I am talking about 1820. What we know about Ampere, it is not Ampere's work. The basic finding came from the Danish scientist Ørsted. In April, it is April 1820, Ørsted was a professor of physics in Denmark, and he invited a few colleagues in the evening in a tea party just to demonstrate and show his beautiful experiment that when there is current in a conductor, just beneath this there was one compass and magnetic needle. It got deflected. Unfortunate thing, he could not make any more statement, any more understanding, any more mathematical formulation after that. And those days it was the practice for small invention or small findings, something like this, they used to write not a paper, no. They used to write the whole Europe, throughout the whole Europe it was the convention. They used to call it pamphlet. That is kind of handbill, one-page note. And they used to distribute amongst the elite group, students, researchers, professors like this. The interesting thing is that, so April to September, I think this pamphlet somehow, some information came to Ampere. And Ampere took only a few days. He got this published in July, September 11 and September 18. Only 7 days it took to give some physical understanding of this phenomenon. Do you follow? It was anyone's observation, I am giving the explanation. This part I have kept for my own note that I collected the information, because he wrote one book after that, and then he wrote after 1828, 29 something. So he collected his works, his memoirs, something like this. But most of the works he did in the same year, within few days. What did he do actually? It is very simple. From your school days you have read this thing. This and that. We are mostly taught about the top one, circuital law. Actually Maxwell used this. I would say the second one is equally beautiful, the law of force. That he really understood the nature of the polarity of fields, magnetic flux, and their interaction, which is very similar to Coulomb's law. So this is the approach for a scientist to get it confirmed what you are talking, what you are getting, whether it is right or wrong. But he did not get much time. He was so happy to do this, he published within 10 or 11 days. That is Ampere. So till today remember Ampere. Only for this work. So don't think that research means is the building of Taj Mahal. No, not at all. Even by sitting, even by doing something at your home, you can make a big contribution to science. Just by your applying your mind, your thought, your passion, your love. Dynamics, electrodynamics term he coined. So dynamical theory, Maxwell probably took this term later on. Oh, yeah, Ampere success. Yeah, I'm written the same thing. The Ampere success. What is the source of Ampere success? He worked on Ørsted. That means if someone works something which is obscure, which is not clear, so you can anytime jump onto this. The right information at right time. Other one could do it. So right information is the contemporary thing. You cannot wait. Science will not wait for you. Third one, scientific approach and logic. He addressed the problem, he looked into the problem. So everyone in this hall, if we tell any story, everyone imagine this story in its own way. there is no correlation. So any problem when it is told to you or in your class, your classmate and you, your understanding are different. The same thing happened in Orsted and Ampere. They did not address the problems, the singular mental thought. That's why one succeeded, one could not. So it was the basis of success as per my perception. What had happened to Faraday? You are late, Mr. Faraday, 1820 to 1831, 11 years of time. So one did within few months. July, August, September, only 2 months. And one had to wait for 11 years. Have you ever thought of that? Is it that Faraday was not that brilliant? Maybe. Let's see. What was the difference? This lower one, it is ampere. You are giving current, you are getting magnetic field. It is Faraday. You are giving magnetic field, you are getting current. Just the reverse concept. But it took 11 years of time. Those days when everyone in science, they were trying to get any problem in a very active way. Why? First one, he did by observation. And the second one, he did it through imagination. He had to imagine. So imagination takes time. Why? Then I read 2 complete books. I'm going to that, and I'm trying to give you the excerpts out of that. Please let me know when I have to stop. Faraday. And that's why I have given some milestone in his career card. Otherwise, it will be very difficult to understand how he addressed this electromagnetic problem which changed the whole civilization. It is not Einstein. It is not anyone else. It is Faraday. In last century, not last century, the century before that, it is the 18th century. No, 19th century. It is the 19th century. The mid of 19th century, the early phase of 19th century, he actually changed the whole civilization, the whole industry, and the whole civilization is based on his discovery. So now see how he could do it. What he was doing that time, 1820s, that is Ampere's discovery, because you see this Denmark, just below Denmark is Germany, just below this France, and the other side it is England. And England was getting almost all the information and news from its own source because Faraday was in London. What he was doing that time? Faraday was just 29 that time. 29, nowadays it's quite enough mature age, and definitely in those days he was grown up, quite grown up. So don't think that Faraday did it in very early age. These are the sources of my points. The lower one was his own autobiography, and it was edited by Crook, his friend, and he has written very nicely few interesting statements. So I am combining these two here. That is the time Faraday came as apprentice. He was a school dropout at class 7. His parents could not spend money, spend time for him to educate him. So he was brought to George Rebo, the bookbinding shop. In England, especially in whole Europe, those days it was the standard practice amongst the rich and educated people to collect some information in the form of handbills or pamphlet and very frequently they used to get it bound to keep it for their son or next generation as book, in the form of book. Faraday is writing that when I first got one book of science, you think of Faraday is getting book of science, means what kind of book it could be? It is chemistry. There is no possibility of having any book of physics. So he got this book, he tried to read it, and he thought, he's writing that I thought that my mother can read it very quickly for me, so I can go to my home, ask my mother, please read it for me, I'll get information. But the next day, the owner came. It was the date of delivery, so I could not read it. So I changed my way of handling the science books. I tried to keep notes during work. That means he was doing the book binding work. So during that time, he was trying to keep notes. After the book was delivered to the owner, he used to go to market to buy some chemicals and do the experiments. The interesting thing happened. In every Friday in London, some scientific-minded people used to gather, like our Shanda, Budh Shanda, Shukra Shanda, something like this, in the evening. He got this information and he tried to attend. He used to sit in the corner because he was just a boy, having no formal education, formal degree. Just out of passion, he used to go over there. One day, one person asked him that, Faraday, are you interested to attend one series of lectures that will be given by Humphrey Davy? Yes. Davy was professor of Royal Institution. He was a big chemist, very famous chemist at that time. So 4 days, 4 lectures he attended. In spring 1812. That is very interesting. I am quoting from him. After attending 4 lectures, a school dropout boy is thinking that he decided, quote unquote, go into the service of science. That was his determination. And immediately he wrote a letter to Davy, sir, I want to work at your laboratory. Did not get any response. Fortunately, he noticed that in a newspaper there was one insertion seeking some lab boy by Davy. Immediately again he wrote, Davy called him. He joined 1830. You see his salary at the time. Just remember, it started 1812. Now you see what big change. I think God made it. It is very difficult to prevent that. 30, 40, Davy, I am not reading it, Davy went for a honeymoon trip. The year before, he married a widow, very rich widow, and the next year they decided to go for a whole Europe trip. And at the same time, he decided that when I am going, definitely I should meet some scientists in my field. So better to take this boy, Faraday. Okay, so Faraday will come with me, carry and help me in demonstration. So he was a Davy. In Italy, when they were driving, Faraday was with him. Suddenly, Faraday asked to stop the car. It is not written over there. Why? The huge limestone was around, some construction was going on, and Davy was a chemist specialist in the limestone. He immediately stopped his car, collected some sample, and he told that this is a totally different type of sample. I never have seen this type of sample, and definitely will get very good publication out of this. But you need to analyze this. Okay, Faraday, I don't have any time. It is now your job to do. That is the first problem, formal problem. We got it from. That is the wireless. How many lecturers? call from my wife. Anyway, so Faraday got this. This is another kind of problem. To every researcher. But now we see how did he handle this. He got this problem in 16. In 1816, he published how many? Six. That is 1 plus 6. 21. He was appointed superintendent. 21. Married, London. He started in 1812. 1822, 1826, the right at the time, he elected Fellow of Royal Society. He became Professor of Chemistry. He became Director of Laboratory of Royal Institution without having any formal degree. Only as a researcher, so a true researcher does not need any formal degree, any formal education. (26 to 31), he worked for two things. One is making of lens for observatory and for industry, consultancy for industry. Faraday was basically a chemist. Suddenly, you see, in 1831, suddenly, I have read the cancellation of contracts. A very peculiar language is writing the letters. He cancelled all his contracts with industry and laboratory. And he wrote this one. It was taken from this. His passion to work for his writing. Now my passion is to work on electricity and magnetism. So now you think, did he get this impetus suddenly? No, it cannot be. He worked with solenoid. Do you remember your school day books? That is not correctly portraying Faraday's work. Actually, Faraday's work was different. Some books may be correct, but during our days in school, we did not get this type of information. Yes, actually, he did this thing. It was this indicator, that is the galvanometer or some kind of deflection material. And here he used two coils. One is the outer coil that is getting electricity, and the lower coil is actually the magnetic field generating body. That means magnet, electromagnet. He never used any permanent magnet which is drawn, which is portrayed. He never used that. He used two coils. So one coil, that is the Amperian circuit. The second coil is equally Amperian circuit, same coil, but the induced EMF is generated in the second coil, and he got this deflection. You might have got from my writing that how many days it took. Seriously, it took only 10 days. 3 weeks later, he made his last experiment. It is as per his diary in 1930 on August, and after 3 weeks he wrote this letter to a journal editor. He read it, and I have marked this term again. That means Faraday tried early. Faraday did work, but it is the time, it is the nature, the human mind, the imagination. So it is a kind of perception, imagination, digestion, again give a thought, again do it. So the final thing may be so simple, but the imagination to tell the new thing to the world, that electricity can be generated out of this type of dynamical relations between the magnetic field and circuit. It took 11 years. That's why in the month of March and April, he was a bit restless. cancelled all this thing. That means in his mind something was going on, that this is the time I have got the answer. So I shall have to give more time to do work on this. So it is a long process, mental process. So I am taking one quotation from Faraday. It is his viewpoint about research, in practical application and utility. I think he made this comment much later when he was mature, quite mature. By enabling the mind. Mind is very important in research. Two things are very important. Honesty, academic honesty, not only 100%, 500% honesty. Even you should not believe your own experiment, you need to repeat the experiment because you are going to tell the whole world about the new thing. So other people will go after that. 100% honesty. Second and third is passion and proper mind, tuned mind. The personal experience. At what time you should stop? Is it the time? Then I will stop right now.
The next session is flexible, so maybe you can take 10 minutes.
I want to listen from the audience. You can translate. It is a kind of language you can translate to in your own subject. But the basic thing is that the scientific approach and problem is like this. So please try and see. PhD, when we were in the state of PhD, PhD was a very catchy term. In circuit, what's that? In the printed circuit board, there are multiple holes they use, and that is basically for filtering effect. From this circuit, DGS came. Later, they removed the multiple defects, they took only one or two. They combined it like this, dumbbell shape. And this group told, don't use too many defects on the printed circuit board because it is going to affect your other circuitry. Use the minimum one and you will get very good result. What is the principle of the defect of a circuit? I think those people they know very good. That is, when current is passing through this, is getting some obstruction in the ground plane, it is take the round path and again they continue. So they give one equivalent capacitance over here and due to the round path coil, again it is from ampere, they are getting some magnetic field. So the equivalent is L and C circuit. So it is purely one LC equivalent circuit. And what is the characteristics? The property? Very interesting property. One band is stop band, one is pass band. You see, vision. That means it is working purely to stop particular band of frequency. That's all. The same principle used. I read this paper in which 1999, Korean Sasumi, Japanese group. I could not understand because by that time I could understand a little bit about antenna. I couldn't understand what is the meaning of giving so many defects. Because they are using the concept of EBG. DGS was announced much later, but published much later in 2000, so it is not much later, 1 year after. So I read the paper and found that they are using this for, you see, they are using only this two because it is the feeding line. They are stopping some frequencies, simple filter. The question came, what is the purpose of these defects? They made some comment which makes no sense. The idea came they're using the defect only for the antenna feed, but can you use it to change the antenna characteristic itself? It is just the feeding filtering characteristics. So that is the first thought. And this was one hand-drawn diagram, and you can see job 1, job 2, job 3. Can you read it? One of my students, it was assigned to one master student. Job 1, job 2, job 3 means I had to do experiment because we had no HFSS, no code, nothing. So only some basic equations, and when you are partnering by some unknown structure, it is very difficult to estimate its characteristics, particularly the radiation characteristics. Without going for full wave analysis, it is very difficult, and full wave analysis to do it for now, next to impossible. So I tried to guess some parameters from this paper and translated it from their frequency to my frequency, and I fabricated 3 samples. It looks like this. It is one microstrip patch and 2 defects, simple defects just beneath this, and after drawing it looks like this. The basic idea was in a cavity, in any kind of cavity, there is the possibility of generation of some higher order modes, and basically the higher order modes create some cross-pole issues, and we need to stop this. How can we stop this? So from our some mental calculation, we completed the work. We measured this in my own laboratory, but problem that our laboratory had the capacity of only X band 10 gigahertz, and you see it is working at 3 gigahertz. So 2 of my students, they came to Kharagpur. They took some data, and those results, when they displayed it to me, it is a kind of success, a kind of indication. I was not very sure about this. Then it was in September 2003, and the next July I left for Canada for a few months, and he was my advisor or host over there. So immediately in the month of July, I showed him that this is the things I could not measure over there. Can I measure in his laboratory? And the anechoic chamber, sometimes it is used even for weeks or months with different groups. That time that was occupied. So he took me to another laboratory in Ottawa. He introduced me to David Lee. David Lee in North America is considered as one of top 3 technicians for antenna measurements. Because when there is very critical measurements, particularly in Boeing and other space agencies, they hire me. I did not know about that. I gave this thing to David and asked him, please do it very carefully. David did the measurement, and I got my expected result. More than 5 degrees separation, that was my estimation. I was very happy. But I could not visualize what I visualized from my own thought process. Physically what happening I could not visualize. 2004, thanks to HFSS version 8 that time. Now you are using which version? 12 or more? 15? Oh Lord. So it was HFSS. So I learned it from a Chinese student. Can you see the trace of the yes, from the conjecture there is some higher order mode. It's absolutely absent when you use this effect. So this technique, any antenna using different ground structure, first paper it was published in 2005. And thoughts, they play in different ways. In the next year, I used the same defect for this this imagination that in neighboring, there is one neighbor, there are two neighbors, to isolate them. There is a mutual coupling, to stop the mutual coupling. This way we can take it. But this type of structure we analyzed for both line, transmission line and antenna. 2005 and 2006, the first two papers are published. I'm not going to all details, I will conclude very soon. Marvelous application was reported by them, the other group, 2009. They told, well, the mutual coupling can possibly to handle or to reduce the scan blindness. That's a big problem in large arrays by data. There are a lot of scan blindness issues, so scan blindness can be avoided. So the first report came. It was 2009. Now you see the scenario, 2006 to 2016. The DGS integration technique. I could not count the exact number, but it is approximately or over 1200 papers on DGS. Now you can find about 10 patents using this technique. It provides a beautiful solution, the unique solution for airborne radar, by which using the same technique you can handle both major problems in air antennas, large areas. The cross-pole, the unwanted radiation, as well as scan blindness. Within few developments, NCAR, National Center for Atmospheric Research, Boulder, they contacted me and tried to get some information and jointly developed one airborne radar antenna. Cannot say actually frequency. It is for the airborne weather radar, and they are now using this technique, and many other industries are using it. I cannot tell the exact specifications. The first book, the technical material, first technical material that was published in this book in 11. In Gargi, it was by Dr. Guha. He has dedicated one chapter using this technique. The Wild Encyclopedia published in 2014, they have included DGS integration technique for antenna, separate chapters, separate information you can find. And the fourth one, it is almost ready, the manuscript. It is a complete book dedicated to this topic, completely considering all the developments into that. So from that, it can be concluded like that. Research is like, it grows like a chain from one to another, from one to another, and one to another. And what you do, the problem means to identify the right link. So when someone does any work, you are addressing this, you are actually adding one link. So research means one big string added by links. And the link should be very authentic, because the next generation will hook on yours. That's why the honesty and clarity in your work, that is very much important for the growth of your work. Not only that, you might be aware of the term citation. People will cite your paper if it is very clear and useful and easy to understand. If it is obscure, too difficult, hardly any people will go for that. So writing paper is one very important thing. Good luck for you. But before concluding, I will add few sentences. Last four are very important. The contemporary papers, even in my, I don't find this trained in my research scholars, my students. Without this, you cannot survive. Contemporary papers, you have to read contemporary papers. You may like it, you may not like it, but you should be aware of the contemporary development and choose good papers, read it, and the rest is automatic. Thank you very much.